Welcome back to Topic 9 for Algebra 1, Solving Absolute Value Equations. In Part 2, we're going to continue working on some more problems involving solving absolute value equations. In our example here, we have the absolute value of 6a plus 3 plus 9 equals 24. With problems like this, what I want you to do first is to isolate the absolute value. So everything with the absolute value and everything inside of it, leave that until the end. Just like we would normally want to isolate the variable, this equation is actually very similar to how we would solve 9 plus x equals 24. If we want to isolate our x right here, we would get rid of the 9 first and subtract it. We're going to use that same process with solving this absolute value equation. So we can still draw our line down. We're going to subtract 9 from both sides. And we get the absolute value of 6a plus 3 equals 24 minus 9, which gives us 15. Now that we have this absolute value isolated, now we can split. So we're looking for something that we could have equate to 6a plus 3 that would give us positive 15 when we apply the absolute value. If we split, this gives us 6a plus 3 equals positive 15, or 6a plus 3 equals negative 15. Here we just have two-step equations, so we can solve for our a variable. We're going to subtract 3 from both sides since we see a positive 3, so we're going to apply the inverse. Again, I'm just doing the same thing on both equations because it will be the same process. We can subtract 3 from both sides, and on the left-hand side it adds to 0, so we're left with 6a equals 15 minus 3 gives us 12, and negative 15 minus 3 gives us negative 18. Here, in order to fully isolate a, now we need to divide both sides by 6. On the left-hand side, it reduces to 1, so we just have a equals 2 and a equals negative 3. Plugging in order to check our work, we're going to plug this in back to the original equation. So we have the absolute value of 6 times 2 plus 3 plus 9 should give us 24. This gives us the absolute value of 15 plus 9, which the absolute value of 15 is 15, plus 9 gives us 24. Plugging in that negative 3, we have 6 times negative 3 plus 3 plus 9 equals 24. 6 times negative 3 gives us negative 18, plus 3 gives us negative 15, so we're taking the absolute value of negative 15, which gives us positive 15. Add 9 to it, and we also get 24. Our next example here, for number 4, we have 4 times the absolute value of b minus 1 equals 24. And again, we're trying to isolate this b minus 1. So we're going to treat this equation as if it were 4x equals 24. What would we want to do first? We'd want to divide. Remember how multiplication is the operation that we don't always see, but this is really 4 times the absolute value. Let's zoom in a little bit. 4 times the absolute value of b minus 1 equals 24. So just like we would with this linear equation, we would divide both sides by 4. We're going to do the same in our absolute value equation example. So divide both sides by 4. On the left-hand side, 4 divided by 4 reduces. So now we just have the absolute value of b minus 1. And 24 divided by 4 gives us 6. Now at this point, we can split. So we have b minus 1 can give us positive 6, and b minus 1 could also give us negative 6. Again, we want to look for values that would equate to what's inside our absolute value here, that would spit out a positive 6. Now we can add 1 to both sides because we see a subtraction here, so the inverse is addition. And we get b equals positive 7, or b equals negative 5. We can now plug it back into our check step. So we have 4 times the absolute value of 7 minus 1 equals 24. This gives us 4 times the absolute value of 6 equals 24, or 4 times 6 equals 24. Plugging in with negative 5, we have 4 times negative 5 minus 1 should give us 24. So we get 4 times the absolute value of negative 6 equals 24. The distance from negative 6 to 0 on the number line is 6 spaces, so 4 times 6 gives us positive 24. And we are all set there. 2 more examples to go. Here we have 3 times the absolute value of 2m minus 7 minus 5 equals 4. Again, we want to isolate our absolute value. So this is really the same thing as 3x minus 5 equals 4. What would we want to do first here? We'd want to deal with that third wheel, that negative 5. So that's what we're going to do. We see that negative 5. Let's draw a little line here. We see that negative 5. The inverse, we're going to add 5 on both sides. On the left side, it adds to 0. On the right, it adds to 9. So we have 3 times the absolute value of 2m minus 7. Here, this is 3 times. The inverse is division. So we're going to divide both sides by positive 3. On the left, it reduces down to 1. So we're just left with the absolute value of 2m minus 7 equals 3. Now, since we have our absolute value isolated, now we can split. So we get 2m minus 7 equals positive 3, 2m minus 7 equals negative 3, and we have a 2-step equation. So this was like a 2-step inside of a 2-step. Oops. There we go. So we can add 7 to both sides. Since we see that subtraction, we're going to deal with that third wheel first, which is that negative 7 in this case. 3 plus 7 gives us 10, so we get 2m equals 10. On the left-hand side, we have 2m equals negative 3 plus 7, which is positive 4. Divide both sides by 2, and we get m equals 5 and m equals 2. Let's plug this in for the check step. So we have 3 times the absolute value of 2 times 5 minus 7 minus 5 should give us 4. It's a little bit of a lengthier one. 2 times 5 gives us 10, and 10 minus 7 gives us 3. So 3 times the absolute value of 3 minus 5 equals 4. Now when simplifying these problems, we want to think about Pemdas. So we're going to work with our grouping symbols first. Here, absolute value symbols, just like I mentioned in topic 1, are considered grouping symbols. So that's why we go to simplifying them first. 3 times the absolute value of 3 gives us 3 times positive 3 minus 5 equals 4. So we have 9 minus 5 equals 4. And that works. If we want to plug in our second value, we have 3 times the absolute value of 2 times 2 minus 7 minus 5 equals 4. 2 times 2 is 4. Minus 7 gives us 3 times the absolute value of negative 3 minus 5 equals 4. The absolute value of negative 3 is positive 3. So 3 times 3 is 9. Minus 5 gives us 4. Our last and final example is the absolute value of 3y plus 5 plus 6 equals negative 2. Now here, I know what you're thinking. You see that negative number right off the bat. However, we have to get rid of our stragglers first, anything that's not our absolute value, in order to make this determination. So we have this this positive 6. So in order to isolate our absolute value right here, we're going to subtract 6 from both sides. On the left-hand side, we're just left with the absolute value of 3y plus 5. On the right-hand side, we have negative 2 minus 6, which gives us negative 8. It's only at this part where we can stop, because an absolute value cannot equal a negative number. So this is called, like we learned about in topic 9 in part 1, no solution. So since there is no solution, we do not need to check. We are all set, ready to go. Thank you for watching part 2 for topic 9 for Algebra 1 on solving absolute value equations.